We're going to take a look now at graphing logarithmic functions. And the reality is that graphing log functions are very difficult to do without using technology. So most times when we graph a log function, we are going to use either a graphing calculator or software such as Desmos. And the reason for that is, as we've seen, it's difficult to calculate log functions without a calculator, except for some that work out nicely. So in order to graph log functions without using technology, which is what we're going to take a look at now, we're going to use the fact that log functions are the inverse functions of exponential functions, and we certainly know how to graph an exponential function. So that's exactly what we're going to do. Looking at this example, we're going to start with f of x is equal to 3 to the x, a nice exponential function. We're going to find some coordinates, we're going to graph them, and then we're going to use the fact that this function here, g of x is log base 3 of x, is the inverse of this, and switch up our x and y partners in order to be able to graph our log function. So let's start with this, f of x. So -2, -1, 0, 1, 2. I'm just picking x values. And now, as you know, I like to start in the middle. So we have 3 to the 0, 3 to the 1, 3 squared. 3 to the 0, anything to the 0 power is 1. 3 to the first is 3. 3 squared is 9. So we have our positive exponents. And now for our negative exponents, 3 to the -1, 3 to the -2, we take its positive partner. So 3 to the first is 3. 3 to the -1 is going to be the inverse of that, or 1/3. And 3 to the -2 is the inverse of 3 squared, which is 9. So this would be 1/9. And now to graph these, as we saw when we did these in exponential functions, they're approximations because the numbers can get very small. They do get very small and very big quickly. So when x is -2, we have 1/9. So, I mean, it's a rough approximation there. When x is -1, we have 1/3. When x is 0, we're at 1. Very important point. When x is 1, we're at 3, we're here. When x is 2, we're at 9, we're off this graph. So we're just going to use these points here. So here's our 3 to the x, and then we would crawl along our asymptote there. So now, let's use this information to generate a table for our logarithmic functions. So these x values are now going to be our y values. So we have -2, -1, 0, 1, 2. And now we have these y values that become our x values. So 1/9, 1/3, 1, 3, 9. Okay, so let's take these points and graph them. So when x is 1/9, so again, rough approximation here, our y is -2, so we're down here. When x is 1/3, again, rough approximation, we're at -1. When x is 1, we're at 0. When x is at 3, here, we're at 1. And 9, again, we're off our graph. So let's connect these, and here is our log base 3x. So here is our log function. There's some important information here. Let's take a look at important points. So let's do this. Exponential, and then logarithmic. So, points. For exponential functions, we have this important point here, 0.01. Logarithmic, the point becomes 1, 0. X and Y change their spots. For exponential functions, we have a horizontal asymptote. I'll abbreviate that. HA, horizontal asymptote, Y equals 0. For logarithmic functions, since X and Y's change place, we have a vertical asymptote, X equals 0, which I will draw in on the graph there that you can see. Our function starts decreasing and we're just going to skim along this vertical asymptote here, X equals 0. And then the end behavior on this end, as X goes to positive infinity, we would be increasing. Okay, how about range and domain here? For exponential functions, our domain is negative infinity to positive infinity, and our range is 0 to infinity. For our logarithmic functions, domain, and where can I squeeze in? Range. And we know that these flip. So the domain here for our exponential function now becomes the range for our logarithmic function. So the range is negative infinity to positive infinity. And our range for our exponential function becomes our domain on our logarithmic function, so 0 to infinity. And let's check our graph to make sure this is indeed so. Our domain, 0 to infinity. So we look here we see that here's X equals 0. We have nothing going on beyond that. So our domain does start at 0 and goes to positive infinity. Our range for our logarithmic functions, negative infinity to positive infinity, we see we will decrease, go negative infinity, and then even though it's increasing slowly, we do go to positive infinity. And then here, just to throw this in, is a comparison. Here's an exponential function and its logarithmic function. This looks like what we just graphed. And then same partnership, here's an exponential function and here's a logarithmic function. This B is in the case where it's less than 1, so it's in this direction, and this would be its partner log function. So two exponential functions. This is when B is the base for the exponential function is greater than 0, and this is when B is, this is the exponential function when B is greater than 1. And here, this is the exponential function where B is less than 1, greater than 0, and then its logarithmic partners.